name is Greg Jeffries, and I am our discipline leader for subsurface utility engineering for Maser Consulting. Today, I'd like to provide a presentation regarding pipe casing integrity and shorted casing investigations. We're going to start out with our problem statement, and our problem statement basically is shorted casings. Underground pipelines, have a tendency to move or settle, and many of the casings, pipelines that are gas or oil related are cased under roadways, under railroad tracks, under various crossings so that the carrier pipe can be easily maintained without having to dig up a substantial amount of the earth. All of these pipelines typically are required to be cathodically protected. And over time, these pipes are all subject to movement, both the casing itself and the carrier pipe. And with that, you have the risk of a metallic coupling, essentially the carrier pipe coming in contact with the casing and shorting or creating an interference for the cathodic protection. Additional problems result from moisture intrusion. So our casings, because their ends might not be sealed or compromised in some way or through a broken vent pipe, the casings may have some moisture intrusion, which then causes electrolytic coupling. Again, another short in the cathodic system that essentially bonds the carrier pipe to the casing pipe and creates an opportunity for corrosion. And so in either of the case where the casing has come into contact metallically with the carrier pipe or electrolytically due to moisture or water content in the casing pipe, you've created an issue that requires a repair. And per the US DOT standards, the statutes, CFR 49, parts 192 and 195, you have to repair this electrical isolation between the two, and the statute provides for 6 months repair interval. So 192 identifies this issue for electrically isolating the carrier pipe from the other underground metallic structures. 195 also provides the same statute, the same limitations. And again, both require a 6-month repair window following identification. So the issue then becomes, where all these casings are, and many of them are unknown, not well recorded, not a lot of great records. In many cases, these things have been in the ground for anywhere from 20 to 50 or more years. There's a great deal of gas pipe that was put in the ground in the early 20th century, in the early 1900s, that is still in the ground and still operational today. Additionally, some changes in the topography surrounding these casing areas have led to the issue where records are no longer applicable. So in many cases, we have found that the original roadway or the original railroad or structure or whatever that this casing was intended to traverse, that facility has now changed substantially. The topography has changed. There was a new roadway built, or the roadway was widened. They shifted the roadway in order to create a highway. They added an entrance ramp that one wasn't anticipated. And so that topography now has changed where these casing ends are. And the records have all been fairly spotty, I guess. And so the way we look at it is we call the records as being suspect. A lot of cases, these records are created from hand-drawn as-builts, some measurements from what at the time were assumed to be fixed structures, such as a curb and gutter, a driveway entrance, a bridge pier, um, so on. And, so that measurement was made. However, now with the topography changes, those measurements are no longer valid. That driveway doesn't exist. The bridge pier was reconstructed and modified or changed or eliminated altogether. The curb and gutter is no longer there, and so on. And at the time, even if they were surveyed, a lot of the datum that was used was not necessarily reproducible datum. So the topography changes created additional suspects in the record data, and made everything questionable with regard to where the actual location of these facilities are. So with regard to that, how do you then find these casing ends and do the testing? So our group has developed a process where we can pretty accurately and regularly um, pinpoint the location of the casing ends. So we take the practices that we're used to using, geophysical instrumentations, which includes electromagnetic instruments and ground penetrating radar, and we apply these processes and amalgamate, if you will, the information that we receive from, and many times a few different electromagnetic instruments and a ground penetrating radar system to get us to the point where we can identify where we believe the casing ends are. And then we use, traditional vacuum excavation to expose and pinpoint that casing end. As you can see from the image on your screen to the left, there is a casing, a carrier pipe entering a casing that we identified and then test hole with a vacuum excavation truck pinpointed and located. So our experience in using these geophysical tools and really a lot of trial and error over the last couple of years about how to interpret the signal results gets us to the point where we have a really good idea of where the ends of these casings exist. And then, as I said, we confirm those ends by utilizing vacuum excavation. So once we've identified where these casing ends are, now we can update a lot of records. We can look at how, what's the best way to access this casing in, and then working with a qualified contractor, we can identify what kind of repair or remediation is necessary to fix this shorted casing event. So the process kind of starts out where the pipeline owner or operator, typically they have a really good handle on their own internal inventory. They have at least records that indicate that there's a casing in the vicinity of a particular area. They may not know exactly where the casing ends are. As a matter of fact, in many cases, they don't know where the casing ends are. But they do have an inventory indicating that they do have casings and that those casings require testing or remediation or what have you. So they provide us with the inventory for us to go out and determine in the field what are the project needs in order for us to perform a specific investigation on that casing and identify where those casing ends are. Typically, what we have to deal with is a pretty substantial amount of permitting. And in many cases, these permits involve the state DOT or the city or county. In some cases, it involves all three. Quite a number of cases involve railroads, which are, present their own particular challenges with regard to obtaining permits to work within their right of way, and they require, special controls, flaggers, so on. So we go out and we perform a field investigation initially to identify what those needs are going to be, what the site characteristics are, and then what kind of traffic controls are going to be necessary in order for us to perform this evaluation. We put that together, submit the permit applications, provide that information to the various agencies that require it. Once the permit is approved and issued, we go out and we apply our techniques performing the geophysical investigation. Again, as I stated, using various electromagnetic instruments and ground penetrating radar, and analyzing those results to make a very educated guess as to the location of those casing ends. Once we've done that, we identify where we believe the casing ends are, and then we bring in our vacuum excavation equipment and we dig on those locations to confirm and pinpoint where those casing ends are. Once those casing ends are identified and exposed, we then map those casing ends with survey grade equipment, and we use reproducible coordinate values, so NAD 83 state plane coordinates, so that from now on, anybody should be able to, with the survey instruments or the survey information, go out and identify the actual location of that casing end. Once we do that, we backfill that casing in, we compact it to specifications, and we typically include a marker ball that also further helps identify exactly where that casing in was identified to exist. We provide a temporary patch, and then we set up with our teaming partner to come out and perform the remediation that is necessary on the facility. So our patch that we leave behind is essentially a temporary patch, although we do use, coring systems. If we're dealing with concrete or asphalt paving, we do use coring systems. We'll typically, in concrete paving, set the core back in place, and we'll use Utilibond so that we have a real firm temporary patch. We'll also use cold patch asphalt in the case where it's in asphalt, and we'll compact that as well to make sure that we have a lasting temporary patch. But then our teaming partner will come and they perform additional excavations so that they can perform the remediation that's necessary, to make whatever repairs are required for that electrical short. Whether it's making some adjustments in the casings to alleviate a metallic contact between the two pipes, or if they have to reseal the casing ends and evacuate any moisture. In some cases, it also involves them slipping spacers within the casings. Some of these are relatively minimally invasive because it only amounted to them resealing the casing end, and some of them have to get a little more invasive. So once they do that and repair it, in accordance with the approved methods and provide a report on that information, then they backfill the location and, with a permanent patch, which is generally speaking much more extensive than the small core patches that we install. Our teaming partner also does things like install new vent pipes or repair vent pipes that were leaking prior. They'll install a new test station, and they'll do everything they can to make sure that that is outside of any particular traffic area. So in some cases, that might mean extending a vent pipe beyond a roadway area, certainly extending test stations to an area that's accessible outside of the right of way. And then, like I said, they do pretty extensive backfill and compaction and permanent patch materials. One thing that I do want to point out is that this process started because there was a problem in that there were shorted casings, and the problem was exacerbated by the idea that these casing ends were not easy to locate. They were not easy to pinpoint because, again, record information was spotty or suspect or non-existent, and there was not a consistent use of a specific survey datum in any way to identify where these casing ends were so that it was repeatable. So the entities, the owner operator entities, were using contractors, regular pipeline repair contractors that were going out and making an excavation to find these casing ends. And subsequently, some of these excavations turned out to be, fairly large. And so those investigations were well into the six figures in order for them to find that. We've been able to refine this process down to a point to where our investigation to pinpoint the location of these casing ends is in the very low five-figure neighborhood. So there's quite a bit of cost savings that are associated with this process. Not only that, we then survey the ends of the casings. We survey the vents and newly installed test stations and whatever repair work that was necessary. And then from that, we create a myriad of deliverables for our clients. And those go anywhere from a CAD file through KML and KMZ files for Google Earth, or shape files for incorporation into their internal GIS system. And then we package that all together, the survey information, CAD files, and so on, along with the test reports, and we forward that back to our client. So with all that, the benefits that come from this are lower cost. So the impact in cost and the impact in time is substantially reduced. The amount of restoration is reduced. Pardon me. And then the client ends up with a lot of better information with regard to where the casings exist. So Trey, I'm going to ask you to pipe in on a couple of these things. Trey Hayes is with me, and I'd like Trey to go ahead and step in and identify a couple of issues that he's had to deal with regard to these casings.
Yes, sir. Thank you. You covered it well, Greg. But like you said, we definitely have taken our time, and in the field, we've developed a process, like he stated, that we've been very successful with. We've been able to find the casings a ton of times, and we were really impressed with how many times we've been able to find it utilizing the method that we've come up with. We've had all types of things. We've had to take somewhere like a mile off of the beaten path that they wanted us to do. We had to get mules and utilivacs and get all the way off in there and get down and dirty with them. But we pretty much have done whatever we need to do to make sure that we came up with the solution that the client was looking for. Greg covered it well. He covered the process well, and I think that we're willing to get out there and do whatever needs to be done to make sure that we take care of the situation that's needed.
Thank you, Trey. So as we come back, identify, what are these benefits? Again, we've developed a process that provides, in our opinion, an advance in how we locate these casings. We've been able to work out how these electromagnetic signals then, vary and change and give us clues as to where that casing end is. We try and confirm that initially with some ground penetrating radar to make sure that we have a good feeling about where that casing end is, and then we confirm that physically by opening up a vacuum excavation and identifying and pinpointing those casing ends. We're also able to help them isolate issues with regard to the problem locations. Certainly the reduction in excavation, unnecessary excavation may be a little overstatement. Certainly the repair of the casings requires excavation, but the idea of doing it with the methodology that we've been able to bring to bear on this reduces the overall size and scope of that excavation. So essentially making a massive excavation unnecessary. We end up providing an enhancement to their system safety and their compliance issues. And then we provide them with reproducible results at the end of this that have a survey deliverable that they can go out and reproduce those coordinates and identify exactly where those casing ends were determined to be. So with that, I'd like to open it up to questions and answers. So please, if anybody has any questions, I'd like to entertain those questions, and certainly type those questions into the chat box, and I'll turn it over to our moderator to let me know what questions we may have received.
Okay, hi, thank you, Greg, and thank you, Trey. We have a question from, looks like Jen from New York, and her question was, what does a typical pipe casing investigation cost?
So that number is kind of difficult to pinpoint, if you will. It's infinitely variable because we have to take into account a number of things. One, are we dealing with, let's just say, a country road or a side street? Are we dealing with a railroad facility? Or are we dealing with an entrance ramp to an expressway or a highway? So in each one of those are particular issues. You know, on a country road, we may only need minimal traffic control or maintenance of traffic items in order to do our investigative work and identify where that casing end is. On a highway entrance ramp, obviously, we're going to need quite a bit more traffic control and advanced warnings to identify where those casing ends are. And then in the case of, say, a railroad casing, we're going to have to involve the railroad and have flaggers and a railroad inspector on site in order to facilitate that work. So, you know, those cost variables are, you know, they have to be addressed on a per case basis. But I will tell you that it is significantly cheaper. Our process is significantly cheaper than the processes that have been used in the past, where essentially they went out with a backhoe and just started excavating until they found the pipe and then dug until they found the casing. So we're able to provide a significant savings over the cost of what was the traditional method of doing this.
Okay, thank you. Just one more question. This is from Kevin in Atlanta, and his question was, actually, I do believe you touched on this, Greg, briefly, but maybe you could just reiterate or just provide a little bit more detail. But he wanted to ask, how do you find the end of the casings before you dig?
Yes, thank you. So we utilize a combination of electromagnetics and ground penetrating radar. And we actually use several different electromagnetic instruments because, you know, frequencies between the manufacturers of electronic instruments, the frequencies are variable. Not everybody uses the same frequencies. Some frequencies perform better on certain pipes than others do. So we use electromagnetics and various electromagnetics and various frequencies, and we investigate cathodic protection frequencies and so on. And we take all of these results and we analyze these results and we look at where they're indicating some flux or fluctuation. And that generally gives us an idea of, you know, that's the area that we need to focus on for our casing ends. And then we'll use ground penetrating radar to try and kind of further prove our suspicions, if you will. And then ultimately with the vacuum excavation system, we perform a spot excavation so that we can pinpoint that casing end. Trey, you have any further input on that?
Once again, you covered it nicely, Greg. I think it's time. We've been doing this for a year, and over time, you look at your EM equipment and you see the small nuances that are that your equipment's telling you, and it's the culture that we spread through our guys to pay attention to their equipment and what it's telling them, and then we kind of bring it back and field notes and we analyze it and we go and we try it again. We've developed the process by continually seeing the same result. You know, something that we continue to see while we were out there, and then we kind of all put our heads together. And that right there gave us a really good starting point, and we started hitting the ends of the casings more and more, utilizing the information that we had ascertained by going out there doing a bunch of utility designations on the casings. We just started utilizing that, and we've been really successful to the point where we think we can't 100% say it's going to be correct all the time, because you have congestion. You might have a bunch of utilities in that area. You know, we've had even things like the traffic signals kind of throw it off a little bit. But if it's in a relatively area where there's not a lot of utilities, we've been able to pinpoint it probably like 85 to 90% the majority of the time.
Beautiful. Yeah, that's a very high success rate. And of course, you know, with the vacuum excavation, with the combination of all of this technology that we're able to utilize, the excavation really is minimally invasive. You know, we're able to, you know, within a couple of square feet, create that, you know, minor excavation, pinpoint that end, and then, you know, not have a giant hole that requires a substantial amount of backfill and compaction. You know, it ends up being a very minor excavation and a minor amount of backfill and compaction and repair.
Great, thank you. And this looks like this will be the final question. Can the location information be uploaded into a contractor's survey gear?
Yes. That's a great question, actually. So yes, we can. Said there are a couple of the ways that we do this, and we like to make it so that we're providing I don't want to say the easiest. It works out to be the easiest, but the most effective way, I think, is the better way to term this. The most effective way for our teaming partner to come in behind us and then perform again, as minimally invasive an excavation as necessary to make that repair. So we can do that by providing a marker ball location. You know, of course, they can go out with a marker ball locator and pinpoint that marker ball, and that's where they're going to dig. Or we can provide that that file for their data collector so that they can go out and reproduce that location and dig where the survey instrument tells them to dig. But yes, and we can provide that information to our teaming partner in a number of different ways to help them get right back to the very spot where they need to go.
Okay, thank you. That wraps up the questions. Thank you.
Well, thanks everybody for joining our presentation, our brief webinar. I hope you gained something out of it. And certainly if you have any questions, you develop a question after this, or would like to contact us to ask us how we might be able to assist you, please, by all means, reach out. The email address is here, surveywebinars@mazurconsulting.com. And we'll be sure to get back in touch with you and help you address any issues that you might have or any questions that you have. Thank you for taking the time out of your day to join us. And I hope you take advantage of the other upcoming webinars that we have. We have quite a few good ones in our queue, and I encourage you to take advantage of them.